Alright. Alright. Um okay. Hello. Whoa. Okay. Cool. So let's just guess we can do. Okay, so we have to write a sim probability function. Monte Carlo simulation, probability of getting a given number of heads, and a given number of flips of a fair coin. So we need to create a file for this. This is part 4. Let's just do exercises. 4.py. Okay. So let's import random since we're allowed to import random. Oh, Pilot does not like that. Can't use import. Missing module docstring. Fine, we'll put a module docstring. Yeah. Okay, import random. Cool, done. Sim probability. Compute the probability of getting a given number of heads. Okay, so let's create f sim probability. Right, so we're taking num heads and num flips. Right, so num flips is the number of times we're flipping each time. So we do 4i in range num flips, right? So we're doing, or no, 1,000, say. Right? The number of trials, and then we need to flip it num flips times. Maybe we can create a list so get dynamic flips each time. So we could say flips equals boom. So okay. So I in range num flips. We basically just have to actually flip the coin now, append it to flips. So we've already imported random, so we do random random. If you have float between 0 and 1, so if random.random is greater than 1, greater than 0.5, or greater than equal to, shouldn't we? Should be 0.5. Then we basically flips dot append. What are we appending? We're appending. If it's a head, we're appending 1. Let's say. Else flips dot append. Append 0, but now we need to have track with each range, right? Am I tripping? I think I forgot how to append to a dictionary, like add to a dictionary. You just add in. Wait, whoa, whoa, whoa. You just do. What am I doing? Yeah, you can just. So we need to grip of create a dictionary, which is all flips, right? So for I in range, instead of putting flips here, we need to do flips here. So it flips this reset to 0. So then it does this. It appends 0 if it's 0. If it's 1, it appends 1. And then it needs to do all flips dot, and then here we need to do an f string of I is equal to the current value of flips. So let's just have it return this for now. Actually, let's just do a test run for a small number. Let's just do 10, and then let's do return all flips. Okay, so let's just do it a print now. Print sim probability. Let's do 1, and let's do no flips 10. Okay, let's just do that just for type of sake, check on the right path. Okay, yeah, so it doesn't append each one. It's only appending 1. Right, yeah. I'm tripping. Alright, wait. Let's add a print statement. So we print all flips here. It's gonna be a little bit big because they're doing 10 things, but okay. So it's only printing 9. So there is different values. So I should be, oh, it's doing that I. Let's switch that with N. Let's just see if that may fix it. And let's remove this print statement. Yep. Okay, cool. That works. So we have now a list for each iteration that we do. But what we need is we need to find the number of times there's num heads. Okay, one way to do this was to iterate over all the things. It's probably a little bit inefficient. Okay, but we have all the list here now. So we do for, let's do k v, or k comma v, in all flips dot items. So this will return, just make sure that, wait, dot dict items, dict dot keys. I know I used this beforehand. Must be tripping, I guess. Yeah, dot items. Okay, thing v for become okay. Go back to where we are. We're in part 4 now. Okay. Yeah. So for k comma v in all those items, now you have access to iterating over each number, like 1, 2, 3, 4, 0, 1, 2, 3, 4, 9. And you have access to each thing. So you say, we need to keep a running tally of, how are we gonna do this? And basically, we need to return a value for the number of heads, because we know the number of flips, right? So we just wait. How are we gonna do this? I'm tripping here. To do this a lot faster. Okay. Wait. we could do like, for example, count, but okay, so we need to add a counter variable. So let's say count none, right? So we say for n for oops, don't want to do that. For n in v, right? For a number in v, we're iterating over all the numbers, and we're saying if num if n is equal to 1, if the number heads, if it's heads, we're appending 1. So if n is equal to 1, then we count plus equal 1, else we pass. We're going to need to write that. We just add a count plus 1. So now we have a count value. Now this is a count value for each k comma v. We're having the count value. But now we need to actually have an array where we say num heads in each flip. This is probably bad naming convention. But anyway, we just do num heads in each flip. Append, and we're doing, what are we appending? We're appending count. And then return num heads in each flip. Just make sure this works. Oh yeah, let's initialize the answer. Okay. Oh, and then we need to reset the count after each thing. So let's just do count. Sure. Okay, so num flips is 10, right? So now we just do for blank in num heads in each flip, or okay, so we need to add another variable here, which is call this num trials. Let's initialize num trials as let's say it's 10 for now. So so we're basically, now we need to basically say so basically we create a new array. So we say for that's right, for in num heads in each. So each number, or let's just make this array over in heads in each flip. This is probably really inefficient though for really large numbers. Well, I guess we'll test it out. We'll see. Just think about how we can make it more efficient. But let's just for now say if number is equal to 1, we'll just do we need another Yeah, this is really bad naming. But then finally we just do num. So basically we return and we need to divide this by num trials. So let's test this out. Okay, so let's just increase this to 1,000. Okay, so let's change this to 5. Should be the expected result. Whoa. Um, let's print. Okay, so clearly this is equal to 0. So let's go to a more manageable number. So let's, oops. Oh, the reason is because num trials is still kind of low. Let's increase that a little. Oh, I'm still printing. It's not good. I should probably keep some keyboard interrupt that. We're lucky it's kind of slow, so let's check this now. Let's check our result now. We'll just do it. So this should go a lot faster. Whoa. Okay. So that's pretty disappointing, but it is what it is. So let's just check. I think we should start. So let's start here. So we're doing 100. Oops. Whoa, whoa, whoa. We'll rerun this. There's no 50. There is almost 50. Okay, it's being updated incorrectly. So I think this is correct, right? Oh, this should be equal to num heads. Oops. Oops. I don't know how I could make that error. Okay. So go 51. Let's increase the trials to 0. Should converge. It's gonna take a second though. Oops. That's actually gonna be very low. There's very negligible. Okay, so there's 0.77 chance of getting 51. And then, okay, what we'll also return is we'll return we should also return the number that comes up most. Interesting sake, but it seems to converge around 51. I can also have it return is, oh, there's no mean function. not a function. Sum them heads in each flip. Yeah, so the mean is right, but there's a pretty low chance of getting exactly sat 50. Okay, but let's just make sure this is right. So